For 20 years, astronomers had a maddening problem. They kept finding rocky planets sitting in the just right zone around their stars. Not too hot, not too cold, but not one of them could prove any of these planets actually had air. On July 16th, 2026, that changed. Meet LHS 114b. It's a super-Earth, a rocky planet about 5 to 5.5 times the mass of Earth, orbiting a small red dwarf star roughly 48 to 49 light-years away in the constellation Cetus. It was first discovered back in 2017, and it's always been a top candidate in the search for life because it sits inside its star's habitable zone, the distance range where temperatures could allow liquid water on the surface. But being in the right spot means nothing if a planet has no atmosphere to hold on to heat and protect its surface. Without one, even a perfectly placed world is just an airless rock. Astronomers had never been able to confirm an atmosphere on a rocky planet in a habitable zone until now.
A team led by planetary scientist Collin Cherubim, working with researchers at Harvard, built a model that combined everything known about LHS 141b. Its mass, radius, density, age, orbital period, and the amount of high-energy radiation blasting it from its star. That model predicted something specific. If the planet had an atmosphere, it should be leaking helium into space. Helium is the second most abundant element in the universe, and it's very light. Light enough to escape a planet's gravity easily and drift outward, making it a useful tracer for detecting an atmosphere from a distance. To test the prediction, the team used the Magellan Clay Telescope in Chile, observing the planet as it passed in front of its star. During that transit, starlight filtered through the planet's outer layers, and specific wavelengths of light were absorbed by helium atoms, a telltale signature. In a lucky break, a second planet in the same system transited on the same night and showed no such signal, which helped confirm that what they saw on LHS 141b was real and not a fluke of the instrument. The result? LHS 141b is genuinely leaking helium, meaning it holds a real, persistent atmosphere that appears to have survived for billions of years. It's the first confirmed atmosphere on a rocky planet inside a star's habitable zone. The findings were published in the journal Science on July 16, 2026. Based on the planet's density, scientists think LHS 114b likely has an iron core and a silicate mantle, similar in structure to Earth, but with a low-density outer layer, likely some mix of water and atmosphere. The helium signal itself isn't the whole story either. Cherubim's models suggest carbon dioxide could be the second most abundant gas, with carbon monoxide and small amounts of oxygen also possible. And his climate modeling points to LHS 1140b potentially holding a lot of water. There's a catch. LHS 1140b is almost certainly tidally locked, meaning one side always faces its star while the other stays in permanent darkness, much like our moon is locked to Earth. And its star is a red dwarf, a type known for violent flares that often strip the atmospheres off close-orbiting planets. The fact that this one may have hung onto its air anyway is part of what makes the discovery so striking. This is the part serious scientists are careful about. There is currently no evidence of life, and no evidence of a life-supporting atmosphere on LHS 1140b. What's been confirmed is that the planet has an atmosphere. Not that it's breathable, not that it's Earth-like in composition, and not that anything lives there. Cherubim has been direct about this, calling it too early to draw conclusions about habitability, while also calling LHS 1140b the most promising laboratory currently known for studying whether rocky worlds beyond our solar system can support life. The team plans new observations this fall, and there are hopes for time on an even more sensitive instrument in Chile. The James Webb Space Telescope is also expected to search LHS 1140b's atmosphere for water vapor over the next several years. And if it's there, that would suggest the atmosphere is stable
rather than a temporary leak. We may not know yet if anything lives on LHS 1140b, but for the first time, we know a rocky planet in another star's habitable zone can actually hold on to air. And that alone rewrites what we thought was possible 48 light years from home.